Welcome back, fellow adventurers. In this episode of the Bitcoin Tech Tales series, we will continue to follow Jane's transaction as it travels through the Bitcoin network. As we discovered previously, Jane's wallet broadcasted the transaction to multiple nodes across the web. Now, it's time to explore what occurs when a node receives Jane's transaction. So, put on your virtual goggles and get ready to dive into the thrilling world of Bitcoin. Are you ready to join me on this adventure? Let's go! Jane's transaction is on the way to the entrance of our miner. Miner lets only data in the Bitcoin format enter the city. After Jane's transaction has passed the check that it is a Bitcoin transaction and that the node has not received it yet, it may enter the node. First, the node checks if the transaction is valid. For this reason, the node transmits it to the verify transaction house. In a node, there are a lot of actions happening simultaneously. So, we will focus only on transaction verification now. Verifying a transaction takes only a fraction of a second, but we will show it slowly for better understanding. Here, in the verify transaction house, the transaction must pass through various checkpoints. We will look at each checkpoint closely. In the first step, we check if the transaction has changed since it left the wallet. For this reason, we compare the ID number of the transaction box with its newly calculated hash. If the numbers are equal, the box's content is authentic. In the same way, we also check the ID of the witness box. Both IDs are identical, so the transaction passed this verification and may move to the next step. For example, if someone altered the transaction after leaving the wallet, the fingerprint of the transaction or witness box would change. Even if only one is not the same, the transaction is invalid, and our defender Boxy knocks it out. Boxy is a true defender. Hackers have no chance. This transaction is not lost. The node will receive the original and unchanged version from the neighbor nodes. Again, the transaction has passed the check and is on its way to the next station. At this checkpoint, the node verifies whether the owner of the certificates used to fund this transaction has approved their spending by digitally signing them. Before we continue with the explanation, let's remember that Jane's wallet manages only one Bitcoin address, and therefore, all certificates used to fund the transaction have the same Bitcoin address. Hence, in our scenario, the node only needs to verify a single signature. Signature creation and verification are Sigy's tasks. His setting here is to verify the signature. Before he can check the signature, he needs the hash of the coupons and certificates used for the payment. In addition, he also needs the public key before he can start with the verification. The valid signature proves that only the private key owner who generated this public key could have produced this signature on this transaction. It attests to the will of the private key owner to make this payment. This signature is valid, therefore, the transaction may pass and forward to the next station. However, the signature verification fails if the transaction signature and the public key are not generated from the same private key. By now, we've learned how a node checks the authenticity of a transaction. We've covered a lot and want to ensure we don't overwhelm you. So, let's wrap up this episode and save the rest for our next episode of the Bitcoin Tech Tales series. Thanks for joining us, and we'll see you soon.